Hello everyone. Today we're looking at Leetcode problem number 3370, which is an easy problem. And what this problem says is that we have to find a smallest number with all set bits. For that, we are given a positive integer n, and we have to find the smallest number greater than or equal to n, such that the binary representation contains only set bit. So let's take an example of maybe n equal to 5. So if I have my binary representation, that would look something like this. So for 5, I have 1 and 1 here, and this is 0. So I'm only consider this. Now, in this binary representation, there is 0 which is not set. So what I need to do is convert this into 1 and return this value, which is 7. 4 plus 2 plus 1 is 7. Now what happens if my n is equal to 3, which is 2, 1, and these two are already set. Now, since the maximum set bit defines like the range, and within that, if everything is already set to 1, then we don't care because we need the smallest number greater than or equal to n. But the important condition is that we should have all set bits. Alright, so the problem is quite straightforward. We can look at the code now. So let's say that we are going to be processing bit by bit. So starting from the rightmost bit, which is the least significant one, I say I is equal to 0. And then I keep processing it. So I'm going to start from this bit, then I'm going to look at the next bit, then next bit, and next bit, and so on. And I'm going to keep doing that till I reach the most significant bit. And I can compute this in Python using a method called bit length. So I can apply this on any integer variable, and this will give me that. So let's say I is less than n dot bit length. Okay, so in case of 5, this would give me 3. In case of 3, this would give me 2, which was this. Alright. Now what we say is that if n at, okay, so let me explain this part first. So what we're doing is we're taking 1 and then we're shifting it by some value. Okay, so if we shift it by 0, we get 1. If we shift it by, let's say, 1, then I get 1, 0. If I shift it by, let's say, 2, then I get 1, 0, 0. So this is the bit shifting that we are doing. Okay, and what we are saying is that, let's say I have the number 5 itself, which we wrote it as 4, 2, 1. 4 plus 1 is 5. And so we are taking this 1, 0, 1 and 1 shifted by 0. So it is just 1. So now we are checking if the least significant bit is turned on. I get 1. Yes, it is turned on. Do nothing. But what happens if I have 1, 0, 1 and 1 shifted by 1? Let's say 1 shifted by 1. Then I get 1, 0. In this case, I am getting, when I multiply here, I get 0. Okay, because we are only looking at this value, and that's all. We don't care whether it was set or not. We don't care. So we are interested in this value. Now this gives me 0. If this gives me 0, then I need to set this bit position on. So let's do 1, 0, 1 or 1, 0. So now that is like an OR condition here. So whatever is here comes here. Here we turn it on, and then this was already turned on. So that is what we're doing. So if the AND operation gives me equal to 0 or not equal to 1, then I will say n is equal to n or same 1 shifted by I. And finally, I can increment I because whether it was turned on or we turned it on, we move to the next bit position, and finally we can return n that we have updated here. So that's about it for the code. It's just 4-5 lines of code. In terms of the time complexity, if you see, we are iterating over bit length. So what we're doing is we are looking at log n steps, and at every step we go from 1, we go to 2, to 4, and so on. So we're looking at these many steps. So if you go to 8, we will get 3 steps, and so the time complexity is log n. And space complexity is going to be just order of 1. That's about it for this problem. Thank you. I'll see you again next time. Bye.